So when we talk about formal charge, basically formal charge is a measure of the extent to which an individual atom within your molecule has either gained or lost an electron. So as we said when we first introduced covalent bonds, it's a sharing of electrons, but it's not always an equal sharing. Sometimes we have a very electronegative atom that's going to take more of its equal share of electron density. So for example, that might have a formal charge of -1 because to some extent it has gained that much electron density that it now has a formal charge that's negative. So when we think about any type of formal charges, we have to assign these based on a formula here, which is very easy to follow. Formal charge equals V minus L minus 1/2 S. It's even easier to follow if we know what all of those stand for. So Fc, I think you all know, is formal charge. Does anyone have a guess for V? Everyone has a guess. Great. Valence electrons. What about L? Lone pairs. So lone pair electrons, actually, not lone pairs themselves. And then S. Good, that's the tricky one. Shared electrons. All right, so this means we can actually calculate this for any molecule that we've drawn the Lewis structure for, because we actually do need to draw the Lewis structure before we know, for example, how many of each of these we have, or at least go through the rules. And what's important to keep in mind about formal charge is if we have a neutral atom, such as we did in thionyl chloride here, the sum of the individual formal charges on the individual atoms within the molecule have to equal 0. So if we add them all up, there should be no net charge on the molecule if the molecule is neutral. So if we think about the second case here, where we have Cn minus, now we're talking about a molecule with a net charge of -1. So that means if we add up all of the formal charges within the molecule, what we would expect to see is that they sum up to give a net charge of -1. So we can do this for any final charge we have. If we have a molecule that has a charge of +2, then all of the formal charges should add up to +2, and so on. So let's just figure this out for some of the examples we did. So for the cyanide anion, so if we want to figure out the formal charge on the carbon, we need to take the number of valence electrons. So that's 4. We need to subtract the lone pair. What number is that? It's 2. And then 1/2 of the number of shared electrons. So shared electrons are the ones that are shared between the carbon and the nitrogen. So we have 6 shared electrons, and we want to take 1/2 of that. So we end up with a formal charge on carbon of -1. We can do the same thing for nitrogen. So in terms of nitrogen, that starts off with valence number of 5. Again, we have 2 lone pair electrons on the nitrogen, and again, we have 6 electrons that are shared. So what we see is that the formal charge on the nitrogen is 0. Also, formal charges can be checked, as I just said. -1 plus 0 should add up to -1 if, in fact, we're correct for the Cn anion, and it does. So we know that we're probably on target in terms of calculating our formal charge. So let's think about our second example, actually our third, but the second one we're going to talk about in terms of formal charge, which is thionyl chloride. So why don't you tell me what the formal charge should be on the sulfur atom of thionyl chloride? All right, let's take 10 more seconds. Okay, so the majority got it. So hopefully next time we do a formal charge question, we'll get everyone back up to speed, but we've just introduced it, so let's go back to the class notes and explain why this is the correct answer. So if we look at sulfur, what we need to do is take the valence electrons in sulfur, and there are 6. By looking at the periodic table, it's right underneath oxygen, so those both have 6 valence electrons. There are 2 lone pair electrons on sulfur. We only have 2 lone pairs, or 1 lone pair, 2 lone pair electrons. And then we end up having 6 shared electrons, 2 from each of the bonds. So we end up with a formal charge on sulfur of +1. If we go to the oxygen atom, now we're talking about starting with 6 in terms of valence electrons again. But instead of 2, you can see we have 6 lone pair electrons around the oxygen, -1/2 of 2, so we have -1 as our formal charge. And if we talk about chlorine, and both of the chlorines are the same in this case, we start with a valence number of 7 for chlorine, and then we subtract 6 because it has 6 lone pair electrons around each of the chlorine atoms, then -1/2 of 2 because we only have 1 bond or 2 electrons in a bond.